Good morning, all of you.
Good morning, sir.
Good morning. Okay. In the last class, we have discussed about osmosis. Okay. In the osmosis, okay, osmosis is nothing but a movement of a water molecule from the region of higher water potential to the region of lower water potential, or region of higher water concentration to the region of lower water concentration through a membrane. Okay, through a membrane. Okay, in the osmosis, only the solvent molecule will take it into consideration, but it depends upon the solute. Okay, that is water potential as well as solute potential. The osmosis depends upon pressure potential and solute potential. Okay, there is. And next, okay, we'll discuss about osmotic pressure. Today we'll discuss about osmotic pressure. Okay, we all know very well. Okay, if two chambers are separated by a membrane with the two different solutions, okay, two different concentrations of solutions, the water will move from the region of higher water potential to the region of lower water potential till the both the chambers attains the equilibrium. Okay, till the chambers attains the equilibrium. At that point, the net movement of the molecules will be from a higher water potential to the region of lower water potential. At equilibrium, the water potential of both the chambers which are separated by membrane is equal. So that's why the net movement of water molecules will be zero. Okay. Okay, whether the okay, even though there is a difference in the concentration during osmosis, the movement of water molecules will occur from higher concentration to lower concentration, at the same time from lower to higher. But the net movement, that means more number of water molecules will be moving from the region of higher water concentration or water potential to the region of lower water concentration or water potential. So that's why we have to observe the net movement. We should not check about how many number of water molecules are moving. Total number of water molecules. We have to observe the net movement. The net movement only will help in from where to where the water is moving. Okay, in equilibrium also the movement of water molecules will undergo across the membrane from one chamber to another chamber, even at equilibrium, but the net movement is zero. That means how many number of water molecules that are moving from A chamber to B chamber, the same number of water molecules will move from B to A. That is what we call it as equilibrium. Okay. Okay, here we can see here. So we have constructed an experimental setup, that is by using a thistle funnel. The broad end of the thistle funnel is closed with the help of a egg membrane or a semi-permeable membrane or selectively permeable membrane. Okay, and in the thistle funnel which is closed with egg membrane, it is filled with will pour highly concentrated sugar solution, and this thistle funnel with the concentrated sugar solution up to certain level is placed in a beaker containing pure water, that is with low concentration than the sugar solution. Okay, and now the beaker is having higher water potential, whereas the solution that is present in the thistle funnel is having higher water is having lower water potential. So the movement of water will occur from the beaker through membrane into the thistle funnel. Okay, when you observe here, so what we are doing, we are taking a beaker with water with low concentration or a pure water with a higher water potential, and we are taking a sugar solution in a beaker, in a thistle funnel up to a certain level, and the thistle funnel with the sugar highly concentrated sugar solution is placed in the beaker. Now what happens? Okay, here osmosis occurs. Okay, during osmosis we already said only the solvent will move from the region of higher water potential to the region of lower water potential, but not the solute. So never sugar molecules will enter into the water that is present in the beaker. Never the sugar molecules will enter into the beaker. That is what you have to understand. So only the water is allowed, but the water that is present in the beaker is having higher water potential when compared to the sugar solution that is in the thistle funnel. So continuously the water will enter into the thistle funnel through the membrane, through the selectively permeable membrane. As a result, okay, so here as there is no movement of sugar molecules, so never the equilibrium attains. Okay, never the equilibrium attains, because there is no movement of sugar molecules across the membrane, only water molecules is allowed. So as a result, what happens? Continuously the water will enter, but as the sugar molecules are not entering from thistle funnel into the beaker, there is no change in the concentration of the water that is present in the beaker. So, okay, in this condition, never equilibrium attains. So continuously the water will enter from beaker into the thistle funnel through the membrane. So in this condition, we never observe attainment of equilibrium, because as the sugar molecules are not passing through the membrane and entering into the beaker, only the water molecules are only allowed to pass through that membrane. So the concentration of the water that is present in the beaker will not change, but the concentration of the sugar solution that is present in the thistle funnel will be decreased gradually because of the addition of water, but still it is having lower water potential than the water that is present in the beaker. So continuously the water will enter into the thistle funnel membrane from the beaker. So never equilibrium attains in this condition. Okay, because water will move into the funnel, resulting in the rise in the level of solution in the funnel. This will continue till the equilibrium is reached. Okay, till the equilibrium is reached, this process will continue. But will equilibrium will be attained? No. In case sugar does not diffuse out through the membrane, will this equilibrium be ever reached? No. Okay, as the sugar molecules are unable to diffuse through the membrane from thistle funnel into the beaker, So we cannot observe the equilibrium attainment in this condition. If sugar molecules, okay, if the membrane permits the movement of sugar molecules, then the equilibrium will be attained. But here what he is saying, in case sugar does diffuse out through the membrane, okay, automatically equilibrium will not be attained. Understood? Anybody is having any doubt in this concept? Okay, we can see. Okay, and next, external pressure. Okay, external pressure can be applied from the upper part of the funnel such that no water diffuses into the funnel through the membrane. Okay, here see, okay, in the B diagram, we can observe, okay, we have taken the sugar solution, okay, sugar molecules, we can see, and we have taken the pure water and sugar solution, okay, concentrated sugar solution in the thistle funnel, which is closed by a beaker, which is closed by a, the wide opening of the thistle funnel is closed with the help of the egg membrane to facilitate osmosis. And okay, we all know very well, during osmosis, the water always enters from the region of higher water potential to the lower water potential. So as the water that is present in the beaker is having higher water potential than the water that is present in the thistle funnel, so that's why the water continuously enters into the thistle funnel. But here, what we are doing means, we are applying the pressure in the opposite direction in the sugar solution to prevent the entry of water from the beaker into the thistle funnel. We are applying some pressure from the upper part of the funnel. That means in this direction, we are applying some pressure on the sugar solution, okay, to prevent the entry of water from the beaker into the thistle funnel. Okay, that what is that pressure means? That pressure we call it as osmotic pressure. Okay, this pressure required to prevent water from diffusing is in fact the osmotic pressure, and this is the function of solute concentration, and more the solute concentration, greater will be the pressure required to prevent water from diffusing in. Okay, that means how much pressure we have to apply to prevent the entry of water through the membrane from a higher, okay, from the region of higher potential to the region of lower water potential. That pressure we are calling it as osmotic pressure, and that is depending upon the solute concentration. If the if the solute concentration is less, we have to apply less pressure because the potential difference is less. Okay, because of the pressure potential. Okay, because the less pressure potential is there. Okay, pressure, okay, that is the difference. The potential gradient is deferred, is very less. Because of this reason, we have to apply less pressure. Okay, if the solute concentration is more, then what happens? More water diffuses from the region of higher water potential to the region of lower water potential, because very low water potential is there if a high solute concentration is there means. So we can more amount of water diffusing in from one region to the other region. From one region to the other region. So we have to apply more pressure to prevent the water. Okay, that is, so that means the more the solute concentration, we have to apply more pressure in opposite direction to prevent the entry water into that solution. Okay, so numerically osmotic pressure is equivalent to the osmotic potential. Numerically osmotic pressure is equivalent to the osmotic potential, but the sign is opposite. Okay, that is osmotic pressure is the positive pressure applied while osmotic potential is negative. Okay, that is okay, the value will be the same. Okay, the osmotic potential, that means the pressure, okay, the pressure through which the water is entering from the region of higher water potential to the region of lower water potential, that is called osmotic potential. Okay, that is having the negative value. That is having the negative value. But whatever the pressure we are applying in opposite direction to prevent the entry of water, okay, which we are calling it as osmotic pressure, that is the same, that is equal to the osmotic potential only, but the value will be positive. Okay, the magnitude is same but with opposite sign. One is a negative, one is a positive. Osmotic pressure is positive, whereas osmotic potential is a negative. Okay, okay, that is what about osmotic pressure, osmotic potential, and osmosis. Anybody is having any doubt? Okay, anybody is having any doubt regarding osmotic pressure, osmotic potential, osmosis? Okay, and next coming to the topic, that is the plasmolysis. Okay, plasmolysis. What is meant by plasmolysis? Okay, the behavior of the plant cells with regard to the water movement depends on the surrounding solution. Okay, the behavior of the plant cells with regard to the, okay, the behavior of the plant cells with regard to the water movement depends upon the surrounding solution. Okay, that means when you observe, okay, if you take a cell, okay, the amount of water or the movement of the water into the cell or out of the cell will depends upon the external environment in which the cell is present. So, okay, okay, regarding the solution in which the cell is present, depending upon the concentration of that cell or depending upon the nature of that environment or in which that cell is present, depending upon that, the movement of the water will take place. Okay, that is if the external solution balances the osmotic pressure of the cytoplasm, that means if the concentration of the cytoplasm of the cell and the concentration of the solution that is present in the external environment is the same. That means how many number of water molecules that are entering from the external environment into the cell. The same number of water molecules are entering from the cell into the solution or external environmental solution. Okay, then we say that the two solutions, that is cytoplasm and the external environmental solution, are in the same concentration, and use a term called isotonic. Okay, here the tonic refers to solution. Okay, that is a solute concentration. Okay, concentration. Tonic refers to solute concentration. Iso means the same. So the concentration of the cytoplasm of the cell and the concentration of the external environmental solution, both are same. That means the osmotic pressure of the cell is the same with that of the external solution. Then we say that the two solutions are in isotonic condition. That is same concentration. Okay, that is. And next, if the external solution is more dilute than the cytoplasm, if the external solution is more dilute than the cytoplasm, it is hypotonic. Hypo means lower. Okay, which is lower? The external solution is lower in concentration. If the external solution is having a low concentration, then the cytoplasm of the cell, then we say that it is hypotonic. Okay, that means the cytoplasm of the cell is a hypotonic to the external solution. Okay, hypotonic to the external solution. And at the same time, if the external solution is more concentrated than the cytoplasm of the cell, then it is called hypertonic. Hyper means more. Hypo means lower. Iso means same. Here, with which it is comparing? It is comparing with the external solution with that of cytoplasm of the cell. Okay, if the external solution is having lower concentration than the cytoplasm of the cell, then we say that the cytoplasm of the cell is a hypotonic to the external solution. Okay, if the concentration of the external solution is higher than the cytoplasm of the cell, then we say that the cytoplasm of the cell is hypertonic. Hypertonic to the external solution. Then what happens? Okay, if the cell is present in a isotonic solution, no problem, because the net movement of water molecules is zero. Because we can say isotonic means we can say equilibrium. Okay, it is present in equilibrium condition, the cell and the external environment. So the net movement of water molecules is zero. So there is no problem. How much number of water molecules entering into the cell, the same number of water molecules will move out of the cell. So it is maintained. No change in the cell also. But what happens when the cell is placed in a hypotonic or a hypertonic solution? Okay, what happens? Okay, what happens means when you place a cell, when you place a cell in a hypotonic solution, that means if you place a cell with a external solution with a lower concentration than the cytoplasm of the cell, then the water enters into the cell because the external environment is having higher water potential. Low concentration means higher water potential, whereas the cytoplasm cell is having higher concentration to the external solution, so it is having lower water potential. So what happens means continuously the water enters from external solution into the cell through the membrane. As a result, the cell will swell. That means the size of the cell will increase because as the plasma membrane is elastic in nature, okay, it can extend. So till, okay, for example, if you take an animal cell, in animal cell, we don't have the cell wall, only the plasma membrane. Till the elastic nature of the plasma membrane is maintained. Up to that point, the water will continuously enter. Once it reaches beyond its elasticity, the plasma membrane bursts. The plasma membrane bursts, leading to the death of the cell. Okay, leading to the death of the cell. Okay. And next, okay, what happens when the cell is placed in a hypertonic solution? Hypertonic means higher concentration external solution and a lower concentration of a cytoplasm of the cell. What happens means the water will comes out of the cell into the external environment or external solution because of the difference in their water potential. Here the cell, the cytoplasm of the cell is having higher water potential, whereas the external solution is having lower water potential. So continuously the water will comes out till the equilibrium attains. As a result, as the water is continuously lost, the plasma membrane shrinks. That means the cell will shrink. Okay, the plasma membrane shrinks or the cell will shrink. It will develop certain wrinkles. Okay, and when you observe here, this process of movement of water from external solution into the cell, when a cell is placed in a hypotonic solution, that means when you place a cell in a hypotonic solution, the water from the external solution will move into the cell through plasma membrane, and this process we call it as end osmosis. End osmosis, that means moving into the cell, end osmosis. And the process, okay, the process during which the water from the cell moves out of the cell into the external solution. When you place the cell in a hypertonic solution, the water moves out of the cell through the plasma membrane. This phenomena we call it as exosmosis because the water is moving out of the cell. Exosmosis. So when you cell in a hypotonic solution, end osmosis will occur. When you place a cell in a hypertonic solution, the exosmosis will occur. Okay, that is some introduction related to the movement of water across the membranes. Okay, in a isotonic solution, there is no movement, no exosmosis, no endosmosis, because the net movement of water molecules is 0. But when you observe the hypotonic solution or hypertonics, the net movement of water molecule will be there. But in a hypotonic solution, the movement into the cell, that's why we are calling it as endosmosis, the net movement. But in case of a hypertonic solution, the net movement occurs from the cell into the external solution. That's why we are calling it as exosmosis. Okay.